Okay, guys. So then now we are going to do like a transition piece, square to square transition piece. So then here we have our front view and we have our top view. As you guys can see for yourself, both of these views, they are incomplete. And this is a first angle orthographic projection. So then what you ought to do first is that you must complete both of them. Let me start with the top view. Then the last one we have here is our seam. Then next things first, then we must complete this one. As you can see for yourself here, there it forms a triangle. So then here there has to be a triangle as well. So then now we're all done with the lines, the seams and everything. So then now what we must do, then we must number the lines, the seams as well. 1, 2, 3, 5. Then we are going to like project them going up. But let me finish up this one other part first. So then here we have like we have 5 at the back, 1 right in the middle, then 2 here at the front. Then here we have 3, then 4 at the back. Then for this one we have A. Then here we have B at the front, D at the back. Then we have C. So then now here the point 1A is our seam. So then here we have to like draw the direction. The direction shows where we are going, like in an anti-clockwise direction, you see. And another thing that you must notice here on the top view and here also on the front view, you can see for yourself that we have a triangulation there already, which means that is already has been dealt with, which means we are okay. We can just start having to draw our true length. So then, as all of them, they are the same length in a way, we can just call them B, yes, respectively. But yet again, we are just going to get their true length because they are not parallel to the XY line. So then now to determine the true length of B, we just need one of the base sides. So then as we will have one of the base sides here, we are going to use the cone method. We're going to measure here. Then we're just going to scribe an arc. After scribing an arc, we join this arc with the base here. After joining that, we project it going up. After projecting it going up, we then join it here. So then now here, A, B, C, D, you see, all of these edges, they are parallel to this because it's right on the top in a way, if I may put it that way, you see. So then these, we can just name them C, 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 C. Yes. So then now as we just determine our true length and we double checked whether they are okay or invalid or wrong, now we can just so much start with our development of the transition piece. So then we're going to start from A, you see. Then we can just draw a line from any angle then we know that A is parallel to the XY line. So then we're just going to have this because it's the true length. Then then we're going to name this 1. So then after naming this 1, we also know that this is the true length. So then to determine how should I put it? To determine 2B, no, 2A rather, we are going to use this edge here. This is the true length of B. Then here we have 2. Then we join the lines. Remember, here it's a folding line. Then here it's an outline. So then as much as we have this now, we are also going to determine, okay, we have B here. So then as we have B here, it's 2A, then right in the middle it's B. So then now AB here is the true length on the top view as much as also on the front view. So then we can measure this here. Then scribe an arc here. So then use the true length of B. We could have used this one as well. There. Then here now we have point B. Small letter B. Then we join using folding lines. Then here we use outlines. Remember, you have to start from the base, and the base is from here using 1. Now we're using 3 now, you see. So then there's 2 there. Because it's our true length, we're just going to scribe an arc. Then here we're going to use the true length of B. Then we scribe an arc. Then now we have 3. So then as you can see for yourself, as much as we have what we just determined now, the others would be so effortless to construct. Here we have a folding line. Then here we start from B. Then inscribe an arc. After scribing an arc, we get our true length. Square the arc there. Then now we have point C. We join the lines, outline. It should be nice and dark. Then we have our folding line. There. We continue with the process, having been it like here we have our true length here. Scribe an arc. Then we use our true length here that we have for P. Then here we have 0.4. Outlines. Folding lines. There, folding line. So then we move from C to D, being it as a true length. Scribe an arc. Then we use our true length for B. Scribe an arc. Then we have D now. Outline. Folding line. We continue with the same procedure from 5 to 4, being it as our true length, B being our true length, then now we have 5 now. Outline, folding line. Then from D to A, back again. Being it as our true length, scribe an arc. Our true length. We have A now. Outline, folding line. And remember now, we started off from A1, and here we have A5. So then these must meet at A1, which means you must also have another construction. Okay, having it our true length from 5 to 1, then having our true length from A to 5. Then we scribe an arc here. Then we are almost done. Then we join the lines here. Here we can just use an outline. and here an outline, because they all meet here. Then from far as we can see that you all can see for yourself that we are done, because you must just notice that you must have outlines that are dark. You see, folding lines, you must just always specify, showing that this is a folding line, this is an outline, using the types of lines. So I think we're okay now. Okay, now we're going to work with from square to round. So then as we're working from square to round, we are working with the circle. The circle, first things first, you must always divide it into 12 equal parts. For that, we're going to use the 60 by 30 set square. So as we have this now, we can just do our seams. You see, the seams, they all join to the base, from the circle to the base, respectively on the 12 divided lines of the circle. So then as we have this now, we can just label our base, then yet again label our seams. Okay, let me start with the base. 1, 2. Then for the seams, we can just label one of each sides, meaning one of the 45-degree. So then now we have to label the seam. Okay, the seam, we can start from this end. Then we're going to just label it as number 5. Then as we have these now, what we must do now is determine the true length. What we can do, we can just start with D. D, which pass through A respectively, and C, which pass through B respectively. Then we can just join those arcs. Then after that, we're going to project him going up. Then we project this one again, because we're working with the other part. Okay, let me just finishing up numbering. Okay, here we have 5, then 4 at the back, 1 at the front, then we have 2 here, 3 at the back. Then here we have the A, B, C, D, E, F, G, H, I, J, K. That I won't mention, but we'll stick to what we have already, because this is a circular, it's a round. Okay, then now what we're just going to do here, we're just going to join this one and this one for us determining the true length. Okay, for the first one, you can see that first C passes through B, then it goes up, then we have here, which means here we have B. I can just use a / C, you see. Then here we have D and A. So then this one is the true length of A / D. So then as much as you guys can see that I'm only having two through lengths. You see, I'm having only two through lengths. Led by that, this is a circular transition, meaning that, as you can see, the arc here passes through from D to A, then from B to C. You see, led by that, that is why I have only 2 arcs for me determining the true length. Okay, so then now from 5, okay, I'm having 5 here. 5 is the seam, you see. Let me just label it as an alphabet. Maybe I can use E, you see. So then the seam of 5, E, is parallel to the XY line, meaning that this is E, you see, is the true length as well, you see. So then as we work from here, we can determine the Thales theorem for determining the circumference of the circle, you see. So then when determining the circumference of the circle, I can just use just a random line, you see. Okay, so then from the instructions there, what we have there, they gave us only the radius of the circle. So then the radius of the circle was 15. So then to work out the circumference, the formula is pi multiplied by diameter. So then pi is 3,14 multiplied by the diameter. As we're having a radius, which means the radius is going to be by 2. Then when it's by 2, the diameter is 30, which give us all in all 94 millimeters. So then there I drew a straight line. I'm going to just measure it using my straight edge here. There is 94 right there. See. So then I'm just going to draw another line for us to divide the line into 12 equal parts. There we have it right there. Let me make it a bit longer. There. Then here, this is going to be 1. Then we're just going to divide the line by 12 equal parts. You can just set your compass to any length, then just scribe arcs using the same length. This is called the Thales theorem. Here you must work by precision for you to get the exact length. Let's see. Just want to fix this. I've made a mistake. There. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh my goodness. There we have it. Then we're just going to join the lines. You hold the bottom base steady, then you slide this. I'm doing this because I want to know the distance between the fold lines. There we have it. The construction here, as we've divided by 12, is just a division showing the actual true length between the segments here, A, B, C, D, going right round. You see. So then now we can start with our development. So then we're going to start from the seam, which is 5E. I can just start at any point. Okay, this is going to be 5E, going down like that. So then as I have this now, 5E, I know that the true length of 5E is right on the front view. I can just take the distance using my compass. Put my needle point there. Scribe an arc. So then as we have here now, we have, this is point, let's see, okay, this is 0.5, this is E. Yeah, this is 0.5, this is E. So then as we have that part now, what we can work with now we are working from E going to the adjacent side being A. So then the true length for A, we have it right there. Then we all know that this is the actual true length from 5 to 1. It's a true length on both sides. My arc was very much short. Let me just fix that. There. So then this is going to be 1. We join the lines. Outline. Fold line. So then as we come back here to this part again, here we are working from, this is A. This is A. This is E, capital letter E. You see, this is the seam. This is A. So then now we must work from A to B. Okay, from A to B, you must first work out the true length. Then here we have the actual true length from E to A. Just going to scribe an arc there. Fold line. Then here you can just draw it in construction because you will see later on. Okay, we're working from A. This is B. So then now we're working from B to C. Excuse me. Here's the true length. We work from the base. We come here. Draw another arc. Then we join. Construction. Folding line. We go on with the same procedure. This was A, B. Now this was C. Now we work out D. D. Having our true length there. We work from the base. we work from the true length that we have here, which was our circumference of the circle. We come here, square an arc. Construction. Folding line. So then now we have worked out the first folding lines that we have from the circle itself. Now we ought to work out from 1 to 2. Okay, from 1 to 2, it's our true length. Just going to square an arc. Okay, from 1 to 2, we start all over again. We start with what? A. Because you can see for yourself that it is seemingly one and the same thing. So then we're going to use the true length of A. You join the lines. This is 2. Outline. Folding line. We repeat the same procedure. Now working from A to B. From A to B. Let's first label this A to B. We determine the true length of B. We work from here, square an arc. Then here we also have our true length here. Grab another arc. Construction. Folding line. We have B now. Then we work again from B to C. Square an arc. Square an arc. Come back here again. Square an arc. Construction line first, then a folding line. Then now we have C now. Then we come back again. We use the true length of D. Square an arc. Then we use the true length from the Thales theorem. Just grab an arc. Then you join the lines. First things first, construction. Folding line. There we have it, D there. Then work again from 2 to 3. From 2 to 3. We're almost done. Just grab an arc. Then from 2 to 3, we start all over again using our true length for A. Just grab an arc. Having here an outline. It's supposed to be dark. A fold line. A again. Then work from A to B. Use the true length that we already have. Just grab an arc. Use the true length that we have from the Thales theorem. You can use any of these. Use the construction. Then here a folding line. Then we work out again another true length that we have for C. We use the true length that we have from the Thales theorem. Construction line. Then here a folding line. There we have it, C. From C, then we have D. Let's grab another arc. Construction. Fold line. Then we have the, here we're having 3. So then now we're working from 3 to 4. 3 to 4 is the true length. Then first things first, we're starting off with A, having our true length. Outline. Excuse me. Folding line. This being A. So then as we're having this as A now, you go to B. Scribing arc. Folding line. Then we have B now. From P, it's C. Determine the true length. Scribing arc. We work from this. Having it the true length. Scribing arc. Construction. Folding line, C. Starting from C, we have another true length. Scribing arc. Work from this to get the true length. Scribing arc. There's D. Then here it's 4. So then remember now we're working from E to 5. And E to 5 is the seam. So then now we must also have another construction from 4 to 5. So then what we have here, we have the true length from 4 to 5. There we have it right there. So then the true length from, we already have it for the true length for the seam. Then we label this point 5. Join the lines. Outline. This is an outline even, because it's connecting to the seam. So then now, here we are only just having construction line. We just need to erase this off. Then connect these lines, because this thing, it's a round shape. So then what you can do is just connect by 3 dots with your neat freehand drawing. 3 dots. 3 dots. There we have it right there. Make sure the line touches the edge there on top. So then there we have it now, the development of the transition piece.